Hello. In this video we will learn about a force called the normal force. Let's say you have a nice desk and you push hard into the desk. Your force is trying to accelerate your hand toward the desk. If you were successful, then your hand would push into the desk and the desk shape would have to change in order for that to happen, or break in half. Hard, solid objects don't usually like to change their shape, as you have probably noticed. When you push on the desk, it pushes back with a force that counters your pushing. We call that force the normal force, and I'll explain why in a bit. So the normal force is a force that a solid object exerts in order to prevent something from pushing into its surface. Let's make this a bit more precise. Imagine you have a cup of water sitting on your desk. Gravity is pushing your cup downwards into your desk. However, we know that your cup won't accelerate into the desk. It will just stay there. So we know that the acceleration is zero. So let's write out an equation using Newton's second law. ma equals the sum of forces. Now we know that the acceleration is zero, so really we have that zero equals the sum of forces. If only gravity was acting on the cup, we would have a problem. Minus m times g is definitely not zero. We know that the cup has a non-zero mass, and g is a non-zero constant. So how does Newton's law seem to fail? Well, the answer is that there is a second force acting on the cup, the normal force. So let's add that to the equation. Great! Now it's possible for this equation to make sense. Now, what is the value of the normal force, and what is its direction? Well, let's solve for it by moving minus mg over to the other side. We see that the normal force N equals positive mg. So that means that the desk exerts a force on the cup of mg in the upward direction. Now, I want to clarify something. You might think that, hey, we have two forces that are equal and in opposite directions. This sounds a lot like our action-reaction law. But this is certainly not a result of Newton's third law, which states that every action has an equal and opposite reaction. That law states that when object A exerts a force on object B, B exerts an equal and opposite force on object A. The key difference here is that action-reaction means two different objects feel opposite forces. Here, in our case, the same object, the cup, is feeling equal and opposite forces, so it does not feel an acceleration. This is subtle and potentially confusing, but very important to note the difference. Now, we could actually apply action-reaction here. The desk pushes up on the cup with a normal force, which means the cup is pushing down on the desk with an equal and opposite reaction force. However, we know our desk doesn't accelerate either, even though it is feeling a force. Why is that? Well, the desk itself is feeling a normal force from planet Earth on which it stands, so the desk is stabilized and does not accelerate. You can actually keep asking this question. Why doesn't planet Earth accelerate? Well, there actually is a clever answer to that question, which I'll leave you to figure out. I'll give you a hint though. There is an action-reaction force we have not yet accounted for that will stabilize the Earth. Go ahead and try to work it out. So let's look at a few other situations where the normal force comes into play. Imagine you have an object against the wall, and you push it towards the wall. Again, it will not breach the wall unless you push very, very hard. So the normal force is balancing out your pushing force, which means it equals the pushing force but is in the opposite direction. Note though that the normal force is now directed leftward, not upward. This is because the normal force acts in whatever direction is required to prevent something from breaching its surface. That means that it always acts in the direction perpendicular to its surface. Another way to say perpendicular in math terms is normal, which is why this is called the normal force, because it acts in a perpendicular direction. Finally, imagine we have a box sitting on a slope. Gravity acts on the box, and you can decompose that gravity force vector into two components, one that is perpendicular to the surface of the ramp, and one that is parallel. The normal force of the ramp will push on the box in such a way as to cancel that perpendicular component of gravity, since that is the force that is trying to breach the ramp. How exactly we determine the values of the two components of gravity and of the normal force is the subject of a different lesson, but I just wanted you to see what it means for the normal force to always counter a perpendicular force. In conclusion, the normal force is a force that solid objects exert to prevent other objects from moving into them. And that's it for this video.